All right, good day, everybody, and welcome to this balanced weather science video. I'm really excited today to have Dr. Sean Ernst from the University of Oklahoma. I'm going to let him give a little more introduction on his background and what exactly he does. And he works for IPRA, and I'm not going to try to explain what that acronym stands for. I'm going to let him do that. But we're going to be talking today about the Storm Prediction Center and the new conditional intensity probabilities that they're going to be, or conditional intensity forecasts that they're going to be including as part of their probabilistic forecast starting next week. And so, Sean, why don't you tell everybody who you are and what you do?
Sure thing. My name is Dr. Sean Ernst. I am a meteorology PhD that works with, as Alan mentioned, the Institute for Public Policy Research and Analysis, which I will note, it's an easier acronym to remember than CIRO. That one's a tricky one. What we do at IPRA is look at communication and risk decision-making problems. So things like, how do people respond when they receive a tornado warning? How do people assume that they're inside or outside of a tornado warning when they hear about tornadoes being around the area? How do people interpret the different words in the convective outlook is a paper that I actually just sent back for review. Those kinds of questions of just how people are interpreting weather information and then making decisions based off of it to protect themselves and their property. So I've had the great fortune of working with SPC on a lot of the questions that they've been asking about how to better present forecast information to the public, including some of the social science work that they requested we do with regards to this conditional intensity product.
Awesome. Well, thanks. And Sean and I go back a ways. We've worked together on a variety of projects over the years, so I'm glad to have him on here today because I know he's done a lot of work in this area and can hopefully give us a little bit of background on what exactly SPC is going to be doing here and why. So I figured we would start by talking about what SPC does now. Essentially, for those of you that aren't familiar, the Storm Prediction Center generates day 1 and day 2 and day 3 convective outlooks, which are essentially outlooks about severe thunderstorm potential for the United States. And they generate probabilities of tornadoes, severe hail, and severe wind within a 25-mile point, or within 25 miles of any given point in the United States. But as part of that, they also right now include in their graphics a hatched area, which indicates at least a 10% probability of significant severe weather of those hazards. And for a tornado, significant severe is considered EF2 or greater. For wind, 65 knot wind gust or greater. And for hail, 2-inch diameter or greater hail. So what they're talking about, what they're going to start doing next week is this conditional intensity, where they're going to utilize various levels of hatching to try to communicate the higher level intensity with kind of greater fidelity. And Sean, could you just kind of, if you don't mind, give us just a couple-minute overview of what they're doing, and then maybe we can go into the background of the research that you did that helped them develop these products.
Certainly. So getting into sort of the history of the development of this conditional intensity product. So back in the early 2010s, we had events like April 27th, 2011, where we had this massive, extreme tornado outbreak, the most tornadoes on record in a 24-hour period in U.S. history, with multiple strong tornadoes claiming hundreds of lives, just a horrific event. But we also have events like the May 20th, 2013 Moore tornado, which was a single, very, very intense tornado that occurred in central Oklahoma in a day that only had a 10% chance of tornadoes occurring within 25 miles of a point, whereas that April 27th event was a 45% chance of tornadoes within 25 miles of a point. But again, you know, this information isn't talking about how severe these tornadoes are expected to be. It's not talking about the intensity of these tornadoes. It's just talking about how likely you are to see any tornado of any strength within 25 miles of you. So the Storm Prediction Center knows that there are certain parameters that can be used to discriminate between environments that have really strong tornado potential and environments that may not be as conducive to producing strong to violent tornadoes. They might be something more like a squall line, where it's very rare to see tornadoes stronger than EF2, whereas you might have something like May 20th, where you have a very strong, you know, you've got large cape, lots of instability in the atmosphere, there's very strong shear, but there's maybe less certainty about whether or not a storm is actually going to form. So the idea behind conditional intensity is that they can add more granularity, more information to the forecast by not just telling you how likely it is to have a severe weather report within 25 miles, but whether or not that severe weather report is likely to be a weaker sort of severe weather event or a stronger one. So they've been working at this in what's called the hazardous weather test bed for over a decade now, where they would ask forecasters to not just forecast the likelihood of storms, but also add these hatching levels. So what they started with was just adding an additional layer. First, as you mentioned, they start with that single layer in the original convective outlook that has a 10% or greater chance of significant severe weather. But they added a second hatched layer, which was intended to communicate more extreme weather events. And back when it was originally developed, the idea was that you would have basically sort of 4 levels of concern. The first of which was no outlooked area at all. There's no likelihood of severe weather, so we're not expecting severe weather in your area. The next level was a non-hatched likelihood outlook, which suggests that significant severe is not expected, but severe weather is still possible. So stuff like that, smaller size hail, weaker than EF2 strength tornadoes, and maybe some gusty winds from some stronger storms. But then you get into that hatched area, and what they wanted forecasters to capture there in testing was that significant severe weather was possible. So you're in that sort of higher end cape and shear space. That means that you can see tornadoes and hail that are a little bit stronger, a little bit larger, maybe wind that might involve something like a squall line with bowing segments that can bring your wind gusts closer to hurricane strength. But then the double hatched was intended to communicate where high impact, significant severe weather was expected. So that's where you're getting into really extremely anomalous cape and shear overlap. You're expecting discrete supercells producing giant hail and strong to violent tornadoes. You're expecting something like a derecho event to occur if you're forecasting for wind, just a very uncommon sort of high-end severe weather event. So that was the original thing that they were testing, and that's actually what we ended up testing back in 2023 and before, as part of a, I believe it was a JTTI grant that we had with the Storm Prediction Center. So what we did—
JTTI being Joint Technology Transfer Initiative, just real quick. So if you're a regular balanced weather reader, you know that that's the program that has supported a lot of research to get things into operations from the research side of the house, and actually is one of the programs that was just moved from NOAA Research over to the National Weather Service. So sorry to interrupt. Please go on, Sean.
To add to, especially because, you know, all of the current issues with research and stuff are all intertwined with the actual research that we're learning about. In any case, what we do at IPRA, what we do best at IPRA is we work with data. We do data collection with user groups, people who are going to be exposed to forecasts and information like that. So what we did was a combination of methodologies. First, we have a annual survey that we issue, one of several that is focused on severe weather hazards. We also do one for hurricanes, one for flooding, and one for winter weather. But for the severe weather survey, we actually showed participants who are members of the public a series. They each were shown one of 3 different forecast options. They either had a outlook that had that 45% probability of tornadoes with no hatching. They had an outlook that had a bullseye with that 40% that had 1 layer of hatching, and they had an outlook that had 2 layers of hatching. And so we told participants that they were in a point A, and the point was the same across all 3 graphics, but the layer of hatching was increased across those 3 forecasts. And so we showed these images to members of the public, and we asked them questions about what would you rate your level of concern, your likelihood of taking action to protect yourself from this hazard. And what we found when we tested people across the country with this survey is that between the no hatching and the single hatching cases, and remember, we didn't tell them anything about like what these different layers mean. All they got was this graphic that shows where they are, and it says that EF2 and greater tornadoes are either likely or very likely for the single hatching and double hatching cases. And so when they were shown these graphics, which again, you can check out in the paper that we wrote. I'll make sure to provide that to Alan, and he can name it in his newsletter maybe. But in the no hatching case, on a 1 to 5, participants said that their risk was about a 3 on average. So right in the middle ground, you know, they're concerned, but not like freaking out about this. A level 5 would be. But then when we go up to the single hatching, there wasn't much change. They're still concerned at about, on average, a level 3 out of 5. So we didn't see much of a shift in the level of concern between those 2 layers. And the same thing we observed for the conditional intensity in terms of likelihood of response. So they didn't say that the members of the public weren't much more likely to respond when shown that single layer of hatching. However, when they saw the graphic with the double layer of hatching, their concern increased to closer to a 3.5 on our scale. So we saw a bigger jump in that level of concern and a smaller but similar jump in their likelihood of response when that double hatching forecast was shown to these participants. So what that tells us is that the double hatching seems to be helping people hone in on like, this is something unusual, this is something serious that I really need to be paying more attention to. There's a number of factors that could be involved there. One of the things that one of my colleagues at IPRA right now, Lauren Harvey, who's studying for her master's degree, is actually looking at whether or not there's an effect of being in the center of or outside of a bullseye in the convective outlook and how that impacts level of concern and likelihood of response. But if people were in this double hatched bullseye, their concern and likelihood of response were a little higher. We also tested this in a survey that we do at IPRA with emergency managers. And we saw a very similar pattern, although interestingly, the emergency managers were maybe a little less concerned at the no hatching level, and then a little bit more concerned for the single hatching level. So there's more of a linear increase between the 3 levels for the emergency managers, which makes sense because they're thinking about the impacts that these different events could have, and more significant tornadoes might need more response from those emergency managers. So that was the first study that we looked at. The second thing we did was we actually talked to partners and did a series of interviews, these things that we call focus group interview, or just focus groups, where we actually bring together several practitioners and ask them, you know, here's this product. What do you think? What would you do if you got this forecast? What kind of information would you want in addition to this? Do you think there's any issues with this graphic? And we also, in this case, with these interviews, we also tested a separated version of this graphic. So instead of just showing this overlaid hatching, where you have all these colors that show the different likelihoods, and then this hatching that goes on top of that, we broke it out so that we said, okay, you could have it in this form, but what if we also had a prototype where there's one graphic that just shows the likelihood, and then there's a separate image that just shows this intensity on a yellow, orange, red scale? And so when we showed participants these options and asked them about it, the two really key things that we learned from them are, number one, they wanted really clear, well-defined definitions for each level of intensity. They wanted it to be very clear, like, this is the probability that we're working with, this is the parameters that lead to this being issued, like what exactly does this level mean in terms of outcomes from the forecast. The second thing that we learned was, in general, these practitioner participants, which were emergency managers as well as broadcast meteorologists, were a little more interested in the separated graphic, because they were worried that this overlaid graphic might be a little noisy, might be a little difficult to interpret. Some of the information might not be interpreted the way that the forecaster intends, which is a really important part of risk communication. If what's in the forecaster's head isn't mirrored in the forecast recipient's head, your risk communication isn't exactly where you want it to be. So it was interesting that they had these concerns and were more interested in this separated graphic where they could kind of present each facet of information individually as part of an overall weather story. So that was the second part of this study. The third part, we went back to our survey and we presented participants with a hatched version of the graphic and then that separated version of the graphic. Now, this time, in retrospect, I would have liked to have done this with double hatching present, but we actually just used single hatching because we were kind of looking for the most common form that we would expect this graphic to take if hatching was present. So some participants saw a graphic that had the hatching overlay on top of that likelihood graphic, and they were in a single hatched area with no double hatching showing up, or they were shown a graphic that just had the likelihood, and then next to it, a graphic that had that tornado intensity forecast with the same terminology of chance of tornadoes, but it was an entirely separate image. So you have these two images next to each other. What we found in this public survey, however, we asked the same questions on the same scale, 1 to 5, of level of concern and likelihood of response. When we tested this with both a hail forecast and a tornado forecast, we didn't find too much of a difference between the two cases, the separated or the hatched. So especially for the hail, the risk perception, likelihood of response, as well as we measured participants' perceived understanding of the forecast, were basically indistinguishable statistically, basically very similar averages. The level of concern was about 3.3. The likelihood of response was about 3.8. The understanding was about 3.8 as well. So on the positive side, sort of that average, that middle ground of 3. The only difference that was close to statistically significant was the tornado forecast risk perception. So when participants were shown the hatching forecast, they had a lower risk perception around 3.1, versus when they were shown the separated graphic, they had a risk perception more closer to 3.25. So there was a little higher risk perception when they were shown the separated graphics. But the forecast response likelihood and the understanding for tornadoes were both very similar, around 3.75 for the response likelihood and around 3.8 for that understanding. So very similar between the hail and the tornado, which we weren't really expecting. Our hypothesis was that the understanding would be better for the separated, because that's what the participants in our focus groups were a little concerned about, but that perceived understanding wasn't really different between the two cases. So overall, in our study, what we recommended to the Storm Prediction Center with our analysis was that based on that partner feedback and that concern and wanting that separated graphic, we suggested that the Storm Prediction Center provide a separated version of the graphic no matter what they do, so that they can have their partners talk about likelihood and intensity in separate images. And we also recommended that the Storm Prediction Center do their best to define the different levels of conditional intensity really clearly, so that partners and eventually members of the public would have a better understanding of what exactly these different levels mean when they were forecast for their area. But besides those two recommendations, we found evidence that there was an increased level of concern when that sort of additional layer of hatching was provided. So it made sense if we're able to discriminate the forecast between these high-end tornado, hail, wind environments and these lower-end environments, if we can do that forecast accurately, then there does appear to be reason to issue that forecast.
Cool. So that's a lot, and I have several follow-up questions. I want to just start for our viewers and listeners, just so we're talking about we have the terminology straight. So when SPC issues just their probabilities of regular severe weather, like whether or not an incidence of any level of severe weather is going to occur, that would be an unconditional probability, right?
Whereas that's the probability of whether something is going to happen.
Right.
The idea with these conditional probabilities is if something happens, that's the conditional part, it is either more likely to be significant or less likely to be significant.
Yeah. But the condition for the conditional is that a severe weather event occurs. In other words, if you're in, say, a 15% probability of hail, you can still have a 10% probability of significant hail and basically what you're saying is if a severe hail report occurs, there's a 10% probability it will be significant.
Which was
right?
The original underlying idea.
Right,
yeah.
Exactly. So with these new levels, so first off, they're doing the double hatch and triple hatch. That is what SPC is actually going to utilize here. And you mentioned having the strict definitions. Are there strict definitions? I've had a difficult time finding them if they are. So maybe I'm just not looking in the right place. So can you elaborate on that a little bit?
I can, and I think it would make sense to do an overall description of what what SPC has settled on and presented as their new conditional intensity product. So what the SPC is doing, like you mentioned, is instead of just that 2 layers of hatching and then no hatching being an option, they've introduced a 3rd level specifically for the tornado and wind forecasts. There are only 2 layers of hatching for the hail forecasts. That's an important nuance there.
That is important.
But for the tornado forecast, what they have are 3 layers of hatching, which they are calling CIG or SIG 1, SIG 2, and SIG 3, and then SIG 0 is when there is no hatching over that likelihood forecast. And for the definitions, what they've chosen to go with is, I can pull this up really quick, or I can pull up a website that I can send you to. But what they're doing is they have SIG 0 is you should expect tornadoes to be of EF0 to EF1 strength. For SIG 1, they suggest that EF2 or greater strength tornadoes are possible. For SIG 2, they suggest that EF3 or greater strength tornadoes are possible. And for SIG 3, they suggest that EF4 or greater strength tornadoes are possible. Now, how they reached that definition is they've actually done some work in how the outcomes look in the different SIG levels when they were practicing it in the hazardous weather test bed with these unofficial forecasts that wouldn't go out to the public, but they were testing to see how these forecasts turned out. And they found that the likelihood of stronger and stronger tornadoes increased across the 3 levels of significance. So EF2 tornadoes made up like the majority of tornado reports in, I think not quite the majority, but a larger chunk of tornado reports for each of the increasing levels. And so that's how they reached that definition. Now, for the wind and hail, they did similar statistics, but what they found was that the statistics for the outcomes in terms of wind speed and hail size weren't quite as distinct as those breakdowns of tornado strength. So for wind, what they have are descriptions of the event occurring. For wind, it is SIG 0 is just, severe wind possible. SIG 1 is that isolated significant wind is possible, where you have, isolated storms producing strong wind gusts. Then SIG 2 is intended for an organized system potentially producing significant wind gusts. So this would be a squall line or potentially a derecho being forecast, where these are storms that can produce significant winds over large areas and over a large period of time. And then the SIG 3 for wind is intended to communicate when an ongoing derecho is occurring, and areas downstream of that derecho are going to be in that SIG 3, expecting significant wind gusts to be very likely in that area. And then finally for hail, the breakdown is that SIG 0, again, hail is expected, but not too much significant hail. SIG 1 is that isolated supercells are possible that could produce large hail of greater than 2 inches. And then SIG 2 is a large hail greater than 3 inches is possible, with multiple long-lived supercells producing giant hail. So those are the definitions they went with for the different levels of significance for those different hazards.
So appreciate those explanations, and yeah, I will definitely include, if you can give me a web page, I will definitely include that when I post the video and post more info on this. So Zach, who's one of our subscribers who's participating today, it actually is a good follow-up, I think, to what you just talked about. And basically what he was wondering is, obviously the way that SPC does the significant severe now, they have a numerical definition. It's a 10% conditional probability of at least 10% probability of significant severe. Does that 10% significant area, is there any way in which that equates with the new definitions?
So for the new definitions, it isn't really as much lined up with probabilistic definitions. Now, the Storm Prediction Center, and I just pulled up while you were asking the question.
And by the way, feel free to share your screen if you.
I actually can do that, I think. Let me pull this up here. I'll do this window here. So what I'm showing here are some slides that the Storm Prediction Center has shared with Weather Service forecasters, and they've been introducing the outlook to emergency managers as well, the outlook changes. But this shows those probabilities of those different tornado strengths based on those conditional intensity groups, which are the CIG levels. And as you can see for that SIG, when the significant tornado parameter, which is what they use to issue these SIG groups, is less than 1, only 7% of tornadoes observed in those areas are of EF2 strength or greater. When you get up to the STP 1 to 4, which is that SIG 1, it goes up to 20%. When you get up to 4 to 7, it goes up to 30%. And then at STP 7 or greater, you get around 40% of your tornado reports are EF2 or greater. So that's the statistics that they use to suggest those levels being, let me show you here, that's sort of like reasonable maximum tornado intensity based on those different SIG levels. Now, the important thing to recognize is that what they want to do with conditional intensity is they want to be able to, for example, issue a conditional intensity area in a 5% tornado likelihood area. So they haven't attached probabilities to these conditional intensities in their sort of main form, because they're trying to highlight the intensity maximum that is expected, less so the likelihood of a strong tornado of that level, which they do have these probabilities that they could have used, but decided not to in the final version of the product. And then again, so this is those reference distributions. So for the different SIG levels, they want it to end up around 1% of tornadoes in a SIG 0 are going to be those EF2 or greater. 5 to 6% are going to be significant in a SIG 1, 12% in a SIG 2, and greater than 20% in a SIG 3. For the wind, they have the target distributions of significant gusts of 13% in SIG 1, 23 in SIG 2, and 34 in SIG 3. And then for hail, they have 17% giant hail in SIG 1 and then greater than 25% in SIG 2. The other key thing to recognize is that the outlook is actually going to be changing a little bit with these significance levels, in that now there's more of a grid that exists, because you can have SIG 1, SIG 2, SIG 3, as you can see on the sort of x-axis here, and those different likelihoods of hazards on the y-axis. And so, for example, you could have a 60% tornado get issued, but if there's no significant tornadoes expected, that's only going to lead to an enhanced in that categorical outlook that the probabilistic and now conditional intensity outlooks underlie. But if you get any significance level or SIG issued for that 60% tornado outlook, it's immediately going to a high risk. You can see similar things with like the 15% goes from enhanced to moderate. The 30% can be enhanced with no SIG hatching, up to a moderate with 1, up to a high with 2. For wind, it's similar, although another thing, a little off topic, but you might have noticed that with wind, they've actually added 2 likelihood levels as well as these conditional intensities. So now they can forecast a 75% chance of wind reports within 25 miles of a point, as well as up to 90% chance of those wind reports. So they can go a little bit higher than they have in the past. The cap used to be 60% like it was with tornadoes. But similar to tornadoes, you add those SIG regions. Now you can bump up from an enhanced to a moderate to a high risk outlook. And then for the hail, hail has never led to a high risk outlook in the original conversion from the probabilistic to the categorical outlook. And it continues to not have a high risk category now, even with the SIG levels. But as you can see, you can get up to a moderate when you have those 45% regions that have a SIG 2 or a 60% region that has a SIG 1 or SIG 2. So I know I kind of got a little off track from the question with these slides. So can you remind me of the question to make sure I answered it?
Yeah, no, the question was essentially, is there a correlation between the current 10% hatched and the new SIG levels? And it sounds like there's really not, and that
Yes.
at least, that's by intent,
Yes.
essentially.
Yeah, the goal was to get away from a probability that was tied to likelihood, because the current 10% hatched means that there is a 10% or greater probability of a significant severe weather report within 25 miles of a point. Now what they're saying is, if a severe weather report occurs within 25 miles of a point, it is likely to have this intensity associated with it. So we're no longer forecasting the likelihood of significant events. We're forecasting the likelihood of significant severe if severe weather occurs. And the really good example of this is dry line days out in the Texas Panhandle, or something like the Enderlin EF5 tornado that occurred last summer, where you have these events where like it's kind of iffy whether or not the cap might break, or if conditions are going to line up just right for tornado, hail, or wind potential. So it might be like not really greater than a 2% or a 5% probability of severe weather within 25 miles of a point. But like if the cap breaks in one place along the dry line, oh my God, these storms are going to be nasty. They're going to be massive. You're going to have violent severe weather occurring, but just where this one storm happens to go up. So what they're trying to do is capture that with, on a day like that, like the Enderlin day, instead of having just a 5% unhatched, because they can't hatch a 5% in the current scheme, in this conditional intensity scheme, they would be able to add 1, maybe even 2 layers of hatching if they were really concerned about those high STP values, to where they would be able to have that 5%, but like if it goes, it's going to be really nasty.
So I think I have a follow-up based on that. So you use the dry line examples, and I think that's a really good example. So I want to pick at your social science expertise here. And so I could envision, in May and early June, having day after day after day in like the Southern Plains of 10%, 5 to 10% tornado risk, but with some SIG level associated with it, whether it's 1, 2, or 3. And you talked about how, and for the people that aren't familiar, essentially the probabilities are what SPC forecasters issue, and then the categorical outlooks fall out of that based on the charts that you were showing. Do you have any concern about emergency managers or the public seeing day after day after day of SIG level 2, say, but with only a 5% tornado risk?
So and this isn't based, obviously I haven't tested this.
Right. I realize this isn't something that was specifically studied.
Yeah. I just got to make sure, I cover my bases. It's like, they have the black box on some medications to where, if you have any bad thoughts, make sure you talk to your doctor. But I would say we know that there's a lot of factors that are related to how people respond to those sort of onslaught events where it's just day after day after day. You have to take into account whether or not the forecast is correct. If you are saying day after day after day that there's going to be severe weather, there's a low chance of severe weather, but if it happens, it's going to be bad, and nothing happens, there is a false alarm effect that we've observed in cases where you have, weather service offices that have really high false alarm rates. There is some increase in distrust in the forecast that occurs there. But that forecast trust decrease that we see pales in comparison to the decrease in trust that we see when forecasts miss an event. So if the SPC didn't issue a 5% with a SIG 1 or SIG 2, and then a violent tornado occurred in that area, there would be a much higher loss of distrust from the public if an event like that occurs. So you really don't want to miss events. It's not great to be wrong all the time. So you do want to try and manage your false alarms, but the big costs in terms of trust in the forecast occur when you miss an event. So my initial statement would be, I think it's okay to have that day after day after day, as long as you have a defensible forecast reasoning as to why you're issuing that day after day. If it's just the pattern and the setup is there and the risk is there and you can justify that risk is there, I wouldn't worry too much about a false alarm effect potentially impacting people. The other thing that would impact people that is less related to the forecast and more just related to how people experience these kinds of onslaughts is just fatigue. I mean, if you're telling people that you're at risk day after day after day, it's going to exhaust them. It's just part of human psychology. If you tell people that there's a terror risk day after day after day, it starts to not mean anything because it's just the new normal. So if you have something like the 2013 sequence in Oklahoma, where you had day after day of these sort of marginal likelihood, high potential impact, or low probability, high impact events, probably there would be a lot of fatigue, and you could see some effects like what we saw between the Moore tornado and the El Reno tornado, where people responded pretty well to the Moore tornado on the 20th of May and got to the center of their homes and took shelter and did things like that. But then for the El Reno tornado on the 31st of that month, everybody panicked and was like, oh my God, there's a chance a tornado is going to hit me. I got to get out of here. I got to get away from this thing. And they all piled onto the highways. And you had, I think people were driving the wrong way down Interstate 35 headed south from OKC to Norman. I mean, that kind of stuff can happen when you have these day after day of sort of it's a trauma, right? It's a trauma response. Like this kind of event can be traumatic. So I think my personal lean would be, I worry more about the trauma response that is just a sort of natural response to that kind of being at risk day after day than I would about a response to the forecast, as long as that forecast is justifiable and defensible.
Cool. That's great. Great insight. I really appreciate that, Sean. I think that's really helpful. So Zach had another question that I want to be sure to pass along. So he was wondering is there any work that you're aware of happening to potentially reanalyze previous outlooks of familiar events using the new conditional intensity graphics, so to essentially so that like EMs or others can better understand what they might expect in future events, if that makes sense?
So I've gone down a few slides in this PowerPoint that the Storm Prediction Center has been sharing with partners, and I've got these what they did was they aren't really reanalyzing past events, but because they were testing the conditional intensity forecasts with prior events, we do have some events from 2025 and 2024 where they did have in-house only conditional intensity forecasts that were not shared with the public at that time because they were still seeing how these things kind of shake out. And so you can see, for example, we have the 14th of March of 2025, which was one heck of a day in the northeast Arkansas. There were a lot of really long track, very strong tornadoes. They actually had a large double hatch region that kind of overlapped with the 15% that was issued on that day. So the operational is on the left there, the conditional intensity in-house is on the right. And that just sort of shows that I would expect it to be similar to the current SPC forecast, in that, you know, there's uncertainty in the forecast. As you can see on this particular event, they had a very broad area that was outlooked with that double hatching, and there really wasn't too much in terms of stronger tornadoes down in the southern end of that outlook. But in the northern half, we saw quite a few. In fact, you can see those green lines are EF3s and the blue ones are EF4s. So there were some really strong tornadoes in the northern half of that outlook. So I think based on what I see here, and then we also have the 2nd of April, which had a large 30% area and a lot of tornadoes that occurred there, but maybe not as many strong tornadoes. You can see that, again, they sort of, with these traditional tornado outbreaks, I expect your interpretation of it is going to be very similar, in that you can notice that the likelihood and the intensity are almost a one-to-one overlap, right? Where you see the highest likelihood of tornadoes is where you see the highest expected intensity. So it's more of those like dry line days where things might get a little bit different. And I think they have an example of that if we move down a few more here. Yeah, so this is that June 20th event. You can see in the official outlook, they had a 10% hatched here, but in the conditional intensity, you'll notice that that hatching actually escapes that 10% a little bit, and they have some areas that were outlooked in the 5% with that conditional intensity that actually captured an EF2 tornado on the west side of that outlook that we don't see captured in the operational outlook. So they're able to sort of move away from that one-to-one overlap that we've seen in a lot of these operational forecasts, and now provide a little more granularity about, like, so for example, the 16th May event, they didn't cover the entire 15% in that double hatching. They zoned in on this southern half of this is where we're really worried about those stronger tornadoes occurring. I think that gets to the, I'll go through these. This is another tornado event. I'll show off some of the wind ones as well. This one is really hard to see because the reports kind of cover it up. But 16th of March, 2025, big wind event in the northeast part of the United States. They had a little hatched area with that 30% that extended into the 15% that really effectively captured those strongest wind gusts, those 64, 73, 82 plus knot gusts that were occurred with I believe, a section of the line that had some bowing segments and did some serious wind there. And then with a more typical derecho, which we saw as well on the 20th of June, that was sort of behind those tornadic supercells, they had a corridor of double hatching in that 30% there that captured those high-end gusts pretty well. And they also captured one of these gusts outside of the double hatching and the single hatching, which is, you know, even if you're outside the bullseye, you can still see some pretty significant weather. For hail, again, here's an example where they missed some of these. Hail is such a tough thing to forecast. I think that's probably why they didn't go with the 3 levels of significance there. They just keep it to 2 because the ability to discriminate to 4 different levels of hail intensity just is not there yet. But with the this example, they caught some of those hailers out in Texas. For the 17th of April, 2025, they caught some nasty hailers. You can look at that line of those significant hail reports on the operational verification. We see that on, they captured that with the double hatching in the conditional intensity. And they also added a northern lobe to that single hatching that caught some of those hail events that were in northern Iowa that weren't as well captured by the operational outlook. So those are just some examples of what they've been seeing in their practice so far. But unfortunately, I don't think they're going to go back. The problem with going back and reanalyzing past events, right, is that we know what happened. So it's really hard to remove that bias from your reanalysis. I think it would be much more interesting to use some of the statistics that they had earlier in this presentation and apply those to something like a practically perfect forecast, or if we could just knock out some of the lower end tornado reports when making those practically perfect forecasts. And developed some verification for those conditional intensity areas that show us what a practically perfect conditional intensity forecast would look like.
Yeah. Yeah. I could see where you could, you could use like the STP to give you, to kind of replicate what you might expect as far as the forecast. But yeah, I mean, I think this in and of itself is pretty helpful, because even though, it's not like going back and trying to analyze, the El Reno day or something like that. It still gives you, a good idea of what you might expect in some pretty well-defined cases from last year. So, all right. Well, it's almost 10 till the top of the hour, and I know you have a hard stop, and I do not want to keep you. Is there anything that you feel like we may have missed that you think would be important to cover?
In terms of the overall discussion, I think we've pretty much hit all the high notes. I think that my personal sort of research perspective is I'm hopeful that the Storm Prediction Center will provide in the future a separated version of this graphic so that you can sort of see the likelihood and the intensity forecasts separately instead of just overlaid like they are in these images. Because I think it can get a little noisy, and it might be that some broadcasters might want to highlight the different areas, like for example that Iowa forecast we were talking about with the hail. They might want to talk about how it's most likely to see hail in this area, but there's this northern area where it's a little less likely, but we could see some of those larger hailstones. And they might want to have like a transition, like a slide transition between showing that likelihood and then showing, but here's where we expect the big hail to be. So I'm hopeful that we'll see something like that in the future as well. But as it is with any sort of forecast product, like the development of these things is kind of never ending. So I think overall it's a good idea to add information and nuance to these forecasts, especially when that nuance is something that the Storm Prediction Center is capable of providing.
Yeah, and that's one of the things that I think was, that I think you made a good point in your paper of that. It seems pretty clear that the forecast skill is there for this, for these products. It's more a matter of the best way to communicate them. And, that's something that, 10 to 20 years ago, the Weather Service would not have went through all of this effort to try to understand, how to communicate it and how partners and the public might understand it. We probably would have just thrown it out there and seen what happens. So it is an awesome evolution that NOAA is supporting this kind of work that you're doing, Sean, and IPRA and social science people at NSSL and GSL. And it's great that the effort's being made to do this on the front end before the products are out there, and it will be interesting to see if and when they add the separated products. So, Zach said, great work. And I know we had a couple of other folks that were on and off. I don't think we have any other questions. So, I guess we'll go ahead and cut it off here. And I really appreciate you coming on, Sean. been a great discussion and explanation, and I think it'll hopefully help people better understand why SPC is going this route and how they'll be able to utilize these forecasts going forward. So thanks very much.
I'm glad I could share some of my time with you today. It's really important to sort of get education about these big changes out there so that people aren't caught off guard and are able to actually get that intended message that the risk communicators are trying to put out there.
Absolutely. All right. Well, thanks, Sean, and thanks everybody for joining. And I'll be continuing to try to do some of these videos as new research and new tools come out, and we'll talk to you all soon.